Yes. Hello my dear students, I welcome you to NEET World. So now we will be discussing the PYQs, the previous year questions of like EAPCET and NEET exam from the topic General Organic Chemistry. Yes. So this will be very useful for you for your preparation when it comes to JEE, EAPCET and NEET. Okay, so I have included all the PYQs of JEE. JEE also I included few questions from JEE and NEET and especially from EAPCET. So this will be highly helpful for all the students of Telangana and AP students especially. Okay, so those who are preparing for EAPCET along with their NEET exam. So this session will be highly helpful. So just look here. The first question here is, number of activating and deactivating groups from the following are respectively. Yes, so there are given few like groups are given here. So identify them, which of them are like electron releasing group and withdrawing group, or ring activating group and ring deactivating group. So we know, let us say here we have benzene ring. So on this benzene ring, let us say phenyl ring, to this some group is attached G. So this G is nothing but the first one, second one, third one, fourth one and fifth one. So out of these given groups, so which is ring deactivating and which is activating? So the number of activating groups and deactivating groups. See, if this G, if out of these given groups, so if that group contains any non-bonding electrons on it, so this will generally activate the ring. So what I am saying, that will activate the benzene ring, therefore we can say ring activating groups. Yes, so here we have oxygen now. So in the first case we have oxygen atom, so therefore we can say, so for example I am writing the first group. See here we have oxygen, so with some ethyl group over here, some alkyl group. Yeah, so these can be donated into the ring. So I can say first one is ring activating group. Yes, and what about this? See, this is attached with a carbon. So which means here I can replace this with, I need to replace this with COCH3. So this is something like carbonyl group, ketone, right? So this is a ring deactivating group and it will withdraw the electrons towards oxygen and it will like withdraw the electrons or deactivate this ring pi electrons like this. So I can say deactivating group. This is deactivating group. So this is deactivating group. Yes, what about this? See here on nitrogen we have lone pair electrons now, which is directly attached to the carbon of this phenyl group. So this I can say this is ring activating group. Okay, let me change the color of this pen. Yeah, so this is ring activating group. Yeah, what about this? So here directly again carbon. So carbon attached to the double bonded oxygen and the next methoxy group, that is nothing but ester functional group. So these are also electron withdrawing group as like this. So it is nothing but this group. Yeah, so this is electron withdrawing group only now. Yeah, so this one and this one is electron withdrawing group. What about sulfonic acid? Yes, there is no non-bonding electrons on sulfur. Like this we can write. Yeah, so if we write like this, again this oxygen withdraw electrons and this will goes this side. Yeah, that is also deactivating group. Yes, so how many deactivating groups we have seen? Yeah, this one and this one. So 3 ring deactivating groups are there, and how many activating? 1 and 2. 2, 3 will be the answer. So option 1 will be the suitable answer for this particular question. I hope it is clear. So how to identify ring activating, ring deactivating? Just it is very easy. So if particular ring is there, let us say benzene ring is there or phenyl group ring is there, on this if a group G is there, so for this if any non-bonding electrons are present like this, so generally we can consider it as ring activating group. If there is no non-bonding electrons, for example here I am attaching carbon on this carbon which is directly attached to electronegative atom with multiple bonds. Therefore what happens to this? So therefore what happens to this? The oxygen, the electronegative atom will withdraw the electrons, therefore here creates a positive charge on the carbon and it will drag this pi electrons from the ring. So we can say ring deactivating. I hope it is clear. If there is no non-bonding electrons on the group attached to the phenyl ring and that is again directly attached to the electronegative atom, so that will withdraw the electrons towards itself, therefore that particular group is considered as ring deactivating group and or electron withdrawing group. If the group contains any non-bonding electrons, so that can be donated into the phenyl ring, I can say the group G as electron releasing group and ring activating group. Okay, I hope it is clear. Okay, now look here, from the following identify the groups that exhibit negative resonance effect. It means minus I effect, it means that should withdraw the electrons from the ring like this. So here it is withdrawing electrons towards the group, here ketone group is there now, so it is withdrawing the electrons, so we can call it as electron withdrawing group, and this effect is called minus M group. What is this? The effect is minus M group or minus effect is minus M effect or minus R effect, negative mesomeric effect or negative resonance effect. Yeah, so identify from the given A, B, C, D, E, identify which is my exhibiting negative R effect, exhibiting negative R effect. Yes, so minus R effect. So identify, so formyl group, so that is nothing but like aldehyde group which is similar to ketone only, no? So same, it will also withdraw the electron, so this is minus R effect it will show. So amino group, so amino are having what, like non-bonding electrons on nitrogen atom. Yeah, so this will be donated into the ring, so that is ring activating, I can say plus M effect, right? This is plus M effect. Alkoxy group is also having oxygen like this, so non-bonding electrons are there, so this is also showing plus M effect, this is also showing plus M effect, but they are asking about minus M effect or minus R effect, because what I told you, to the phenyl ring. Yeah, so here the carbon is attached, to that carbon if there is any non-bonding electrons, we can expect that that can be donated into the ring, but there is no non-bonding electrons when it is attached to electronegative atom with multiple bonds like this. Okay, so since there is no non-bonding electrons and carbon to donate into the ring, but again here you can see this multiple bond also which is attached to the nitrogen will be dragged towards that electronegative atom and creating partial positive charge, electron deficiency on this carbon, therefore it will withdraw the electrons from the ring, therefore we can say this groups as minus M groups or minus R groups, and the effect is minus R effect, therefore I can say this is also minus R effect or minus M effect. Same story applicable for nitro group also, this is also minus M effect or minus R effect. So nitro is stronger, minus R effect. I hope this is clear, and also I think every one of you know that we already covered all these topics, and you can go through the playlist if you want, and you can watch all those videos which are highly helpful, and you can able to solve very quickly when you are watching those videos, and you can come back to this before solving or before watching this. I think that will be more helpful. Okay, so now look, so how many are there minus M effects are there? A and the next D and E. So A, D, E, we have option C with A, D, E option. I hope it is clear. Yes, so then next consider the following three resonating structures. Yeah, so there is a special video we have already made for this resonance and how the resonance structure has to be drawn. So you can watch that also if you want. So for more clarity, as of now I will be explaining here. So how can we arrange the based on the stabilities order? So in order to write the stability order, we have to follow few points. So while writing the resonating structure, those resonating structure is more stable, which is having more number of covalent bonds. What I am saying? More number of covalent bonds which is neutral. Yeah. So out of these three, see the middle one is having more number of covalent bonds, which is a neutral having more number of covalent bonds. So I can say 2 is more stable. Then next from 1 and 3, how can we decide? Yeah. So there is one more statement. The negative charge should be present on the more electronegative atom and positive charge should be on less electronegative atom. Yeah. So here, look here in the first case, in the first option, the negative charge is on oxygen atom which is more electronegative than this carbon, and positive charge can be on low electronegative atom. It is fine. But when we compare to this, see positive charge is placed on the more electronegative atom which is least stable. Therefore, I can say 2 is more stable than 1 and which is more stable than 3. I hope this is also clear. Very simple na? So where is the option we have? So 2, 1, 3. So option A is correct for this particular question. Then next, yeah, so number of deactivating groups, yeah, so whatever we discussed previously, so based on that you can able to answer this question. So try to give a solution for from your side. Yeah, see, sulfonic acid we already discussed. What about sulfonic acid? Sulfonic acid is minus M group or ring deactivating group. See, on OH we have non-bonding electron, therefore it will releases the electrons into the system, so this will be activating group. So they are asking about ring deactivating groups. Yeah, nitrogen here again it is having lone pair electrons, so this is releasing groups only, both are activating group, these two. And here carbon attached with the double bonded oxygen which is having ester family here, ester functional group. So I can say this is minus M effect or ring deactivating group. Yes, this is ring deactivating. And what about alkyl groups? Alkyl groups are plus I groups and they show hyperconjugation, therefore they are ring activating groups, I can say. So we can say this is ring electron releasing groups or ring activating groups. So what are the ring deactivating groups? Here we have this one and sulfonic acid. And what about chlorine? Yeah, so here you need to remember one thing. So on chlorine we have lone pair electrons which are non-bonding electrons. Yes, so these non-bonding electrons are donated into the ring. Okay, that is fine, but the minus M effect of halogens will be more dominating. Therefore we can say halogens are weak ring deactivating groups. What I am saying? Halogens are weak ring deactivating groups. So finally, what are the deactivating groups? Here we have one is chlorine and another one is sulfonic acid group and the last one is this ester group. So these are the ring deactivating groups are there in the given given species. So what are the what is the exact answer for this? Yeah, so option B will be the very suitable answer for this particular question. Yes, let us move further. So which of the following compound does not exhibit geometrical isomerism? So how can we identify whether a compound is showing geometrical isomerism or not? Yeah, so geometrical isomerism we know that there will be cis trans isomerism, EZ isomerism, those things, right? So how can we identify here? So given all of them are unsaturated compounds, yeah, so first structure you can write but2-in. Yeah, so how can we write but2-in? So I can write but2-in, so this is butane, so this will be but2-in. So this is a trans form because hydrogen and hydrogen. See, alkene, this given alkene is planar with respect to this carbon and this carbon. Yeah, because sp2 hybridization for these two carbons now. And here the methyl group, here this methyl group and here this methyl group are 180 degrees to each other. So we can say trans, this is trans but2-in, and we can also write cis but2-in in this form. See here, two same groups are on same side of this double bond. So I can say this is cis, this is trans. Yes. So option A shows geometrical isomerism. What about option 3 here? Option B here, Higgs. So here, so how can we write? 1, 2, 3, 4, 5, 6. Yeah, 6 hexane it is. He is saying about 3 hexene. 1, 2, 3 if I write. So this will be the hex3-ene or 3 hexene. See here, we can put one hydrogen above and one is like opposite direction with 180 degrees to each other. So this can be trans form. So we can also write putting these two hydrogen same side. So that will be giving us cis form of this 3 hexene. I hope this is also clear. So AB will show cis trans isomerism or geometrical isomerism. Next, what about but2-enol? So how can we write but2-enol? So these are the 4 carbons we have, and on the last carbon I am writing like this, on this first carbon, second carbon I am writing double bond. See, these two hydrogens here we can place cis to each other and trans to each other, I mean same plane or same side of the double bond, and like in the opposite side direction we can keep with 180 degrees, that is what the transform. So this can also show geometrical isomerism. They are asking which does not exhibit. So here styrene will not be exhibiting geometrical isomerism because, so here you can draw the structure, this is benzene. So now to this, so this will be the styrene formula. Yes, now look here, here one side of this carbon both are hydrogen only, we cannot differentiate like what is the position of this hydrogen with respect to this. So we cannot differentiate because these are equivalent now. So when on a particular atom, when this like in this kind of situations, so we cannot able to distinguish whether cis and trans form. So there is no cis trans isomerism in styrene. So option D will be very suitable answer you have to choose for this particular question. So which one is does not exhibiting? Styrene does not exhibit geometrical isomerism. It is clear, I hope. Next, number of possible aromatic benzenide isomers for C6H4Cl2. Yeah. So write this. Yeah. So what is the degree of unsaturation? If you calculate for this, you will be getting 4 as a degree of unsaturation. Therefore, I am writing benzene ring. Yeah. Now on this 4 hydrogens and 2 chlorines are there. So if it is simple benzene, it is C6H6. Remove 2 hydrogens and replace with 2 chlorines. So those chlorines I can place 1,2 position. Yes. Then next I can place them 1,3 position and I can place them 1,4 position. Therefore, these are the 3 possible isomers we will be getting for this aromatic benzenide system. Okay. See, there is no confusion because they only mentioned it is aromatic benzenide system. So this is the molecular structures possible for this particular chemical formula. So option B will be suitable for this particular question. Next, which are the following carbon ion is least stable? So how can we say whether a carbon ion is least stable or most stable? So this is completely based on the groups attached with that carbon anion. So here we have nitro group and here we have alkyl group and here we have aldehyde group and there is no group attached to this. Yes. So out of these 3, carbon anion is stabilized when electron withdrawing group is attached. Yes. So this is minus M group and this is also minus M group. Okay. Now what about this? This is plus I group, right? So we know minus M groups, electron withdrawing group stabilizes the carbon anion, right? Okay. So it means here in these 2 options might be our correct, there will be one option. Now tell me which group will strong minus M group, I mean which group will withdraw the electrons more effectively? Yes, nitro group will be stronger withdrawing group, electron withdrawing group. Therefore, option 1 will be most stable carbon anion. After this, this will be the most stable. And then next, here now tell me which is least stable. How can we say? If electron withdrawing group is there, that is most stabilized. If electron releasing group is there, that is least stabilized. So it means this will be the least stabilized because it is releasing the electrons. Already it is having negative charge and this is releasing the electron, therefore decreases the stability of this carbon anion. Now tell me, yeah, for this particular answer least stable, if they ask, you can directly choose the answer. But my question is, arrange them in the increasing or decreasing order of their stability. So which is more stable I am writing first. So A will be more stable, then B, then after this C will be least stable and D here and C here. So I hope this is very clear how we are writing the stability order. Electron withdrawing group increases the stability of carbon anion, therefore A. This is relatively less electron withdrawing nature than this, therefore it will be the next one. And see, here there is no group, it is better and more stabilizing than this one. I hope it is clear because this plus I group or electron releasing group decreases stability of carbon anion. Okay, next. This is very easy. See, all the questions which I brought here is completely PYQ question. No other question other than the PYQs. Only previous year questions of NEET and EAPCET. Yeah. So here, Yeah. So tell me, species A, B, C, D formed in the following bond cleavages. See, this bond, like this arrow mark represent movement of two electrons. I mean a pair of electrons movement will be shown like this. So for example, A, B are having a bond like this. So now the movement of these electrons will be represented like this. Complete electron movement is taking place towards B. Therefore, it creates A plus and B minus. I hope it is clear. Similarly, here they are shown similar thing. See, this bond is completely moving towards iodine. Therefore, I minus we will be getting, B will be I minus, and A will be CH3 CH2 plus. I hope this is clear. Okay. Now, here copper is attached to alkyl group. We know copper is like metal which is attached to the non-metal. Therefore, these electrons will be shifted only towards non-metals like this carbon side, and creates here CH3 CH2 minus, and D will be Cu plus. Yes. Now choose the answer option which is having these four options, like A will be this one, yeah, B will be also correct, yeah, C will be also correct, yeah, D also correct. So first option is a suitable answer for this particular question. I hope it is clear. Next, try to find answer for this. The electron displacement effect observed in the given structure is known as, yeah, see what I told you, if electrons withdraws from the ring, so we can say ring deactivating group, and effect is called minus M effect or minus R effect. Yeah. So these electrons, see here we have a carbon, to this carbon pi bond with oxygen, like multiple bond, like pi bond and sigma bond with oxygen. So these pi bonded electrons are moving towards oxygen due to electronegativity of oxygen, and that is creating positive charge in this carbon. Therefore, it will withdraw the electrons from the ring. Therefore, I can say this is minus M effect, because electron withdrawing is taking place now, that is by minus M effect or minus R effect. So we can go with option B. I hope it is very clear. Okay. Next, assertion reason question. This kind of questions are also very important. Yeah. Look here, carboxylic acids are more acidic than phenols. Yes or no? Yeah, always remember carboxylic acids are more acidic than phenols, because this is having acid functional group like this. Now when it is releasing this H plus ion, when it is losing this H plus ion, like when it is showing its acidic nature, it will be forming carboxylate ion. So this carboxylate ion will be stabilized by resonance, equivalent conjugation we can say. This carboxylate ion is stabilized by equivalent conjugation, which is more stable than normal resonating forms. Like in phenol, so after releasing this H plus, so it will be forming phenoxide ion. So this phenoxide ion having normal conjugation with this phenyl ring. Here it is having equivalent conjugation. Equivalent conjugation is more effective than this normal conjugation in this phenoxide ion. Therefore, carboxylic acids are more acidic than these phenols. I hope it is clear, because we need to check for this. In order to express the acidic nature of a particular organic acid, we need to check the stability of its conjugate base. The conjugate base of carboxylic acid is more stable than the conjugate base of this phenol. I hope it is clear. Okay. Now, the resonance structure of carboxylic acid ion are equivalent, yes, while the resonance structures of phenoxide ion are not equivalent, yes. So that is what I am saying, equivalent conjugation and non-equivalent conjugation. Yeah. So assertion is correct, reason is also correct. So both A and R are correct, and R is a correct explanation of A. So we can go with option A. I hope it is very clear. If you have any doubts, write in the comment box. Yeah. So arrange the following in the decreasing order of their basicity. Already we discussed about the basic nature of basicity of amines in our mesomeric effect concept. So here, look, out of this A, B, C, so if there is any aromatic amines and aliphatic amine comparison is there, so always remember aliphatic amines are more basic than this aromatic amines, because, so here let us write RNH2, this consider it as aliphatic amine, and here I am writing aniline for our understanding. Yeah, so this is aromatic amine. So in aromatic amine, the lone pair electrons of this nitrogen always involved in the conjugation. Okay, so therefore that decreases the basic nature of aromatic amines when we compare with the aliphatic amines, because aliphatic amine lone pair electrons are set like it is located here very freely without any conjugation, and they are easy to accept the like proton. So therefore we can say more basic nature for aliphatic amines than this aromatic amines. I hope it is clear. Now look here, this is aromatic amine, this is also aromatic amine, but this is not aromatic amine because it is not in conjugation. I mean, compound is aromatic, but these electrons are not in conjugation, right? Because there is no conjugation with this carbon, because it is sp3 hybridized carbon. Therefore I can say these electrons are available freely to donate to the H plus ion or to accept the H plus ion. So I can say B is more basic. What I am saying, B is more basic. Now compare C and D. So when it comes to C and D, when it comes to C and A and C, so here look what kind of groups attached to this ring. So here it is electron releasing group and this is electron withdrawing group. See, what do we mean by basic nature? Basic nature means the tendency to accept the H plus ion or tendency to donate this lone pair electrons to the like proton, right? So now check here which is having more tendency to donate out of this C and A and C, because we know B is more basic because of its aliphatic or non-conjugation of this lone pair are free to accept the H plus ion. Yeah. So here this is strong withdrawing group now, nitro group, therefore it will withdraw the electrons and these electrons effectively participate in the conjugation with like nitro group, which is minus M effect, which strongly hold the electron towards into the ring, and therefore it is less available to accept the proton. So I can say C is least basic, whereas A having like electron releasing groups or ring activating groups, and these electrons are donated into the system, into the ring, therefore these will be easily donated to the H plus ion. So I can say A is more basic than this C. So first is B, then A, then next C. Yeah, you can write like the B, A, C. This is the order. So option B will be the answer for this. Yeah. So arrange the following in the correct order of their acidic strength. Yeah, given phenols with some groups attached at the para position and meta position, identify them. So how can we say the acidic nature of phenols? See, they may ask acidic nature of phenols or pK order of phenols, or they may also ask Ka order of phenols. So all these things are related to same concept only. Look here. So phenol, just now I told you, phenol acidic nature, like acidic nature of organic acid depends upon their conjugate base stability. More stable the conjugate base, more is the acidic nature of this respective acid. So for example here we have this many phenol derivatives. So out of these, which is more acidic means the respective conjugate base has to be stabilized. So how that it will be stabilized, let us look here. So here I am taking phenol, okay. So after, like if it is saying acidic nature, so this is acidic proton now. So I am removing this acidic proton, therefore we will be getting phenoxide ion. This will be the phenoxide ion, okay. So now this phenoxide ion has to be stabilized. So here it is oxygen with a negative charge now. So how that will be stabilized? If there is any group, any electron withdrawing group, so that will withdraw this negative charge into the ring or towards itself, therefore that will stabilize this negative charge of this oxygen more effectively. So I can say minus I groups or minus M groups, electron withdrawing groups, stabilizes this phenoxide ion. So now out of this 4, the one which is having, the phenol one which is having electron withdrawing group, that will be more acidic, okay. So I am writing minus electron withdrawing groups increases the acidic nature of phenols, acidic nature of phenols. All these things already we discussed during the mesomeric effect concept. You can just go through the playlist and you can watch those are highly helpful here for your preparation and understanding of this kind of questions. Yeah, so this nitro group is strong minus M group, so that will withdraw the negative charge and that will increases the stability of phenol oxide ion, and therefore that will results to the more acidic nature of respect to phenol. So which is more acidic here? Fourth one will be more acidic because this is at the para position. So mesomeric effect works at ortho and para position, but not at meta. So at meta position we need to check only for the inductive effect. Yes, so here we know this is electron withdrawing group, this strong electron withdrawing group, and this is what alkyl groups are electron releasing groups. So we required electron withdrawing groups, therefore they increases acidic nature, and electron releasing groups decreases the acidic nature. Electron withdrawing groups increases the acidic nature, electron releasing groups decreases the acidic nature. I hope this is clear. Now tell me, so here electron withdrawing group is there, but it is at meta position. Yeah, so that is fine because it can work out with the inductive effect. Therefore I can say fourth is more acidic than 3. Then next, out of these two, this is a simple phenol, and here electron releasing group containing phenol. So simple phenol is more acidic than this electron releasing group containing phenol. So I can say 1, 2. So which option is there like that? 2, 3, 1, 2. Yeah, yeah, 4, 3, 1, 2. Yeah, 4, B option is correct. Yeah. So I hope you are following the class. So will you answer this question? Like exactly whatever we discussed previous to the previous question, same concept you can apply here. So these are the phenols. Here it is having alkyl group, here it is having alkoxy group. So what I told you, alkyl groups are electron releasing groups, and alkoxy groups also. What about alkoxy groups? So these are also electron releasing groups, and this will be work with plus M effect, and this we can see hyperconjugation and also plus I effect. Which is more dominating? Mesomeric effect is dominating, as these lone pair electrons are given into the ring. But what we required, if minus electron withdrawing group is there, that will increases acidic nature. If electron releasing group is there, that will decreases acidic nature. So this is stronger electron releasing group, therefore this will be least acidic. So I am writing 3 will be least acidic. Then next, after this is electron releasing group, this is one also. So I am writing 2, and which is more acidic? There is no electron releasing group, therefore 1 will be more acidic. I hope it is clear. 1, 2, 3. Now I am adding one more option. Here I am adding phenol at para position aldehyde group. Yeah. So tell me, so keep this in this arrangement. So now tell me, let us take this as 4. Yeah. So where do I need to place this fourth option? So fourth option is having electron withdrawing group. This will withdraw the electrons, therefore that increases acidic nature of phenol. So I can keep fourth option, I can write here, which is having stronger acidic nature than these 3. I hope this is also clear. Yeah. So now tell me for this, even for carboxylic acids also. So electron withdrawing groups increases the acidic nature of carboxylic acids also. Yes, tell me. So which is stronger minus M effect group? Here it is cyano group, it is CN cyano, and here we have nitro. We know nitro group will be stronger minus M effect like showing group than the cyano, so therefore C is more acidic, then A, and least is B. I hope this is also clear. Kyab. Okay, so option B. Okay, so how we are answering this kind of questions? So we need to check for the stability of their conjugate base. So conjugate base will be stabilized by electron withdrawing groups for phenols and carboxylic acids. Yeah. So now tell me, what about carbocation like stabilizing order? Here you can check here, this is phenyl group attached with the CH2, like this carbocation, benzyl carbocation we should call. Okay, and this one you can see there are 2 alkyl groups attached to this positive charge carbocation, and this is vinylic carbocation, this is ethyl carbocation. Now look here, so what is the stabilizing factor here? We have mesomeric effect by these pi electrons, resonance effect I can say, therefore this first one is more stabilized carbocation. Then next, here 2 alkyl groups are there, so I can say 2 plus I groups are there, and to these are the 2 alpha carbons and hydrogens are alpha hydrogens. So totally how many alpha hydrogens are there? 6 alpha hydrogens are there. So 6 hyperconjugations are possible for this. Similarly here we have one alkyl group, therefore 1 plus I effect I can say, and how many hyperconjugations we can say? 3 hyperconjugative forms we can say, like this. So you need to apply inductive mesomeric hyperconjugation for each of these intermediate stability orders to find like carbocation, carbon, anion and free radical in order to get the final answer. See here I have applied. Is mesomeric effect works here? No, because there is no pi electrons to donate. Done. Next go for the hyperconjugation. Hyperconjugation will be there because this is alpha carbon, therefore 3 alpha hydrogens are there, so 3 hyperconjugative forms will be possible, and alkyl groups are plus I groups, therefore I can write like this. So first one is having mesomeric effect which is dominating, then next here more number of alpha hydrogens, more is the stability, therefore 1, 3 and 4, and the least is this vinyl carbocation like this. I hope it is very clear. Okay, consider the following. So arrange them in the increasing order of the stability. Yes, tell me which is more stable. Yeah, just match here. Decreasing order he is saying na. So decreasing means one which is more. Yeah. So see here. This one also included. Alkyne also there na. See, double bond, triple bond. We know triple bond is having more electron negativity than this double bond, therefore this will be least stable carbocation. So I am writing here 5. Yeah, so same option here, first one 1, 3, 4, 2, 5. Yes, option A is correct. Next, the delocalization of sigma electrons into CH bond of alkyl group with pi electrons of benzene. So what he is saying, delocalization of sigma electrons with the pi electrons of benzene. So these are the pi electrons of benzene. Okay, to this carbon is attached. On this carbon, let us say CH group like bonds are there like this. Okay, so what he is saying, the delocalization of sigma CH. Yeah, these are the sigma CH of an alkyl group with the pi electrons of benzene. Yeah, so these are the sigma electrons now. So now we know the conjugation like this is nothing but like for this double bond we can say this is alpha carbon and hydrogens are alpha hydrogens. Therefore, we will be getting a resonating structure like this. See, it is donating now. Yeah, we can write like this. So this effect is what? This is hyperconjugation or no bond resonance we can say, or Baker and Nathan effect we can say. So these are the names for this particular effect, and look here, it is there as hyperconjugation effect here. So option B will be most correct for this. I hope it is clear. So how many hyperconjugative hydrogens are there here? So 3 alpha hydrogens. So 3 hyperconjugation resonating like 3 hyperconjugative forms will be like possible for this. I hope it is clear. Next, which of the following is not explained by hyperconjugation? Yeah, so hyperconjugation explains the stability of carbocation, and the next stability of free radical and stability of alkenes. Okay, and the next stability of alkenes, but it will not explain the stability of carbon anions. So there is a special video only based on hyperconjugation. You can watch that for more clarity. So it will not explain the stability of carbon anion. So we can go with option 1. Next, arrange the following free radicals in the correct order of their stability. Yeah, so free radicals, carbocations are having similar order when it comes to the stability, because both are having electron deficiency na. So carbocation will be having 6 electrons which is diamagnetic, and free radical is having 7 electrons which is paramagnetic because of odd electron, and both are lesser than the octet number na. So we can say both are having electron deficiency, therefore order will be similar for both of them. Okay, now see, these many free radicals are given. So tell me where the free radical is more stabilized. Yes, so if you observe this properly, try to write the structure clearly, then it will give the like correct answer for solving. Yeah, So like this we can write, this can be called as tertiary free radical. So this carbon is surrounded by 3 carbon atoms, therefore carbon is called tertiary carbon, and the radical is there, therefore tertiary free radical. Okay. Now here to this carbon, these are the alpha position carbons, therefore how many alpha carbons? 3, and hydrogens are here 3, 3, 3. So 9 alpha hydrogens are there, so 9 hyperconjugations are possible. So more the number of hyperconjugative structures, more will be the stability. That's why this will be having 9 hyperconjugative forms, this will be more stabilized. So I am writing 4, and then next here, look here, this is having 2 alpha carbons, therefore 6 alpha hydrogens, so 6 hyperconjugative forms. I am writing 3 here. Then next, out of these 2, yeah, so like just whatever the information we got to know, so from that we have these 2 options. Yeah, so remaining, yeah, this is methyl free radical, and see here this carbon is attached with the more electronegative, I mean double bonded carbon, which I can say vinyl free radical, which is the least stable. So least stable means I am writing 1 here, the remaining 2 will be here. I hope it is clear. So option B. So sometimes whatever the concept we know, so apply that, so from that you can eliminate, use the elimination method, so that it will be more easy while solving. Which are the following, in which of the following hyperconjugation is not possible? So in order to show hyperconjugation, the criteria is there should be at least 1 alpha hydrogen. Okay, look here, for this carbon, so for this carbon, so we can draw like this, CH3, CH3, CH3. Now see here, this is the like phenyl carbon which is attached here, and this, let's consider this is alpha. So now on alpha carbon there is no alpha hydrogen, there is no directly attached hydrogen like this. In order to participate in the conjugation or hyperconjugation with this ring pi electrons, therefore so hyperconjugation is not possible in option 1. I hope it is clear. But you can check for the other options, there is 1 alpha hydrogen, if this is alpha carbon, hydrogen is alpha hydrogen. See, there are 2 alpha hydrogen, so 2 hyperconjugative forms can be obtained. And for this alpha carbon, and for this carbocation, this is alpha carbon, yes, here also 2 hyperconjugations we can write for this particular structure also. Yeah, so B, C, D hyperconjugation is possible, but not in A. I hope it is clear. Then next, identify the molecules which have sp hybridized carbon from the list given. Yeah, so try to identify which is having sp hybridized carbons. Yeah, so ethane nitrile, you can write structure like this. Yeah, this is having sp which have sp hybridized carbon. Yes, this is sp hybridized carbon. Then next, butadiene, buta 1,3 diene, so 1,3. So here when it is having like 1 double bond, we can say this carbon is sp2. All the carbons are sp2, but they are asking about sp hybridized. That is not there in option 2. Let us go with this one, propa 1,2 diene. So carbon. So like this, prop means 3 carbons should be there, 1 position, 2 position, double bonds he is saying 1,2 diene means yes. Like this you can write. So in this, you know, for this carbon it will be sp2. For this there are 2 sigma bonds, so we can say sp hybridization. For this it will be sp2. Yeah, so based on this particular one, there will be like frequently asked questions are there. Identify the hybridization from the given compound. Like, so you need to identify based on number of sigma bonds present around the carbon. See here, you can write this in this format. See here, 1 sigma, 2nd sigma, 3rd sigma. So 3 sigma bonds you can say sp2, one s, 2nd one p, 3rd one also p. So totally sp2 you can say like this. For this it is sp2. For this only 2 sigma bonds are there, this one and this one. So I can say for this particular one it will be sp. For this it is sp2. Similarly for this also sp2. For terminal carbons it is sp2 and middle one sp. I hope it is clear. So I can say 1 is having sp hybridized carbon, 3 is having sp hybridized carbon, and we know ethane means what? Acetylene or ethane means like this we have to write. This is also having both are sp hybridized, okay, because only this side 1 sigma and here also only 1 sigma is there, remaining are pi. So number of sigma bonds gives the what like hybridization number or steric number. So if 2 sigma bonds are there, sp, if 3 sp2, if 4 sp3, like that. I hope it is clear, okay. So fourth option, I mean fourth one, first one, fourth one, first one, fourth one and third one will be having. So benzene we know C6H6, all carbons are sp2, therefore the suitable answer is 134, 134. So option D. So very easy questions are there in EAPCET, like previous year questions, you can go through once again, okay. So for every question you just take some time, pause the video, take some time, give try from your side, then listen to the class, okay. So here for the following radicals the correct order of their stability is yes, okay guys. So with this question, so I wanted to tell you that, so this question and also just take the screenshots. So whatever we have practiced till now, so that is enough, I hope. So whatever the questions which I am projecting here, so take the screenshot of those and try from your side. So I will be uploading a recorded video of these like solutions, whatever the questions I am showing now. So I will be uploading a recorded video of this, so you can check your answers in that video. So that will be more effective than listening to my class itself, okay. So just give a try from your side, take some time and give a try from your side for all of these questions. Yeah, take the screenshot. Yeah, so give a try for this. For all these questions you have to try, you must try these questions, because once if you are clear with this, we can able to play with organic reactions very effectively. So see, I will just show you one reaction. See, simply if you are knowing answer for this particular question, so we can solve a we can solve the reaction questions also, reaction mechanism based questions also. Look here, which are the following is most stable form of form for the given structure. See, the given compound is like this. We know this is primary carbocation. What is this? This is primary carbocation. So this primary carbocation is less stable, therefore it undergoes a rearrangement, like carbocation rearrangement, by shifting of this methyl group to here. So what will be getting by shifting? So we can get something like this. By shift of this methyl, we will be getting a tertiary carbocation which is more stable. So for this, so look what are the options we have in this format. Yeah, so in this format, most stable form of the given structure. Yeah, so guys, there is no option as like this, but see 1 2 3 4 5 1 2 3 4 5, this will be the most stable form of this particular carbocation, which is not given in the given 4 option, which is more stable form of the given structure. Yeah, so this will be the most stable form of the given structure. So now I will be explaining you one question based on this. Look here. Like this I have okay. Now this is a carbocation. Now to this, this is a species. To this I want you to add HBr. So what I am saying, add HBr. We know HBr is acid and it will release as H plus ion. So when it is releasing H plus ion, this OH and this H plus, dehydration takes place now. Upon heating, dehydration takes place. Therefore, what is the carbocation generated? To this we are adding this H plus. Therefore, here removal of water takes place and here we are getting a primary carbocation like this. Yes. So after this, what I want to do, Br minus has to be added there, but since this is primary carbocation which is least stable, so it undergoes rearrangement from this primary to tertiary by shift of this methyl group, and we will be having a tertiary carbocation like this. See, if it is shifted over here, so this yellow color group is nothing but this shifted one, and here it is going along with the sigma bond now, so this carbon will be getting positive charge. So now this is what I have written over here. To this we need to add our Br minus, therefore our final answer will be like this. I hope it is clear that you got some idea how this carbocation intermediate stability will help us doing the chemical reactions. Okay, so this is about the class. So this is about the class. So I will be showing you few more questions. I have brought lot of questions, so just give a try from your side for all these questions, and you can cross verify in my next recorded lecture of this particular like remaining questions, because you need to practice from your side also, right? So keeping that in my mind, so I have brought these questions for you. Write the stability order of this carbon anion. Yes. Look here, electromagnetic effect, we know that is temporary effect, but he is saying permanent effect. Like that, it is directly statement based question. You can also solve this. Yeah. So identify the species which is having coplanar. All atoms should be in one plane. So like that, if you identify this is sp3, this is also having sp3. So these are non-planar. So here this methyl group is sp3, this is also non-planar. So here all carbons are sp2. So which is a planar molecule. Like this, very simple, you can just give a try from your side for all these questions. So I will be uploading the recorded of these questions. Yeah, so give a try for this question also. And similarly to this, so this is very important question. This is from JEE mains question, but it is highly helpful for your NEET and EAPCET also. Yeah, so both questions are of similar concept, cross conjugation we can say. What is the concept name here? Cross conjugation. I will be explaining in the recording session. So just now take this and try from your side. Yeah, so these are the questions which I wanted to show you, I hope you enjoyed the session very well. So if you have any difficulties in understanding this kind of concepts, so you just write in the comment box. We will be discussing in the upcoming sessions. So thank you for watching. Happy learning. ఏంటిది